Welcome, students. Starting with the next video with uh, isosceles triangle, we are starting with the next theorem, which is if the bisector of the vertical angle of a triangle bisects the base of the triangle, then the triangle is isosceles. First of all, we have a triangle that is that having a vertical angle which is bisects by a segment um, that it will be clear when we draw some diagram here. So we have a triangle here, okay, then making it a proper triangle. So this is the triangle we have, and a bisector from the vertex is corresponding to the another face of that triangle, and we have that this and this will bisects by the line. This is the A, B, and this one is C. Okay. So the angle A is bisects by the AD, bisects by the AD. Okay. Now we are taking triangle ABC. That is, we have a given what is given to us that a triangle is a triangle ABC in which AD is the bisector bisector of angle A meeting BC in D such that DD equals to DC. Okay, this one. Here we have a sector that is BD equals to DC because of this particular segment that is AD. AD bisects angle A as well as it bisects the base of the triangle that is DC and BD. Both are at equal distance. Okay. Then come to prove what we have to prove here. What we have to prove here can make it different color so that we can understand it easily. That triangle ABC is an isosceles triangle. Okay, we have to prove that this ABC triangle is a isosceles triangle. Okay, this one is AD and this one is AC. We know that if the triangle, when we call a triangle is isosceles, then the two sides of the triangle will be equal, so that AB equals to AC. Okay, AB equals to AC. We have to prove that in further. So we have proof here. Now we change the color so that we can understand it clearly. Proof So for this, now starts with the proof. Oh, first of all, we have to construct something so that we can easily, okay, it is not visible here. So we have to change our color to purple. Okay, construction. Now we have to do a construction that is produce the AD to a certain point E such that AD equals to DE. Also join the EC. Here we have. Now we are extending this one to a certain point and match this one to a certain point. Okay, and we say that this one is point E, so that AD equals to DE, which is this one, and we have to join EC also. Okay, is it clear here? Okay, now further we have to prove what we have to prove here, that ABC is a isosceles triangle. How we will prove? We can consider here. Okay, so in triangles, in triangles A, D, B, and EDC, that is this one, A, B, B, D. Okay, and EDC, this one. This both triangle we have considering here. Okay, we are considering this triangle. Okay, now starts with this proof. Okay, then BD equals to DC, as we have proved here, and it is given also, given. So AD equals to DE. AD equals to DE by construction, by construction, and angle ADB equals to angle EDC. So by the SAS criterion, criterion congruence, criterion congruence, sorry, criterion of congruence, triangle ADB equals to triangle triangle EDC. Here we have clear that AB and AD EDC are congruent. Okay, then AB equals to EC. and angle angle BAD equals to angle angle CED by CPET. That is, oof, that is corresponding part of congruent triangle. But here we have angle BAD equals to angle CED. BAD equals to, sorry, CAD. Okay, that will be this one. Angle BAD equals to angle CAD, as we have both the angles are bisector by the bisects by the AD. Okay, so further, angle CAD equals to angle CED. Okay, therefore, therefore, AC equals to EC, which is side opposite side opposite to equal angles are equal. Equal angles are equal. Okay, therefore, so that so that mm, AC equals to AB, which is proven that here, which which is clear that AB equals to AC, which shows that hence triangle triangle ABC is an isosceles triangle as the sides are equal. When the sides are equal, as we know that the condition of isosceles triangle, that is one side and the another side will be equal, then it is a isosceles triangle. Okay, so we have proof here. Thank you.